You guys able to hear me? All right. Well, let's get going. I'll share my screen there. Wrong one, I think. Alrighty, there we go. All right, hi everyone. My name is Van Olson, and I'm a high school senior from Reston, Virginia. So one thing that has shaped my childhood is my experience with wheelchair accessibility. When I was a toddler, my mom was diagnosed with multiple sclerosis, and that's a disease that limits the brain's ability to send signals to muscles. And so progressively, my mom's mobility has decreased, and she's gone from a cane to a walker to a wheelchair. And due to this transition, I've seen the challenges that wheelchair users face out in the world. There are 2.7 million people in the United States that use a wheelchair, and it can be a difficult experience. John Morris, who's a wheelchair user and a travel blogger, talks about the obstacles that wheelchair users face and the effect that they have on dignity. Because those problems, the problems that wheelchair users have, a lot of the time are ignored and they can just be excluded. The world doesn't always realize the problems that wheelchair users face. And wheelchairs work perfectly well on flat ground, but they can't go upstairs. They can't get over a curb. And buildings are often designed from an abled gaze without really disabled people in mind. So a step in front of the door might prevent a wheelchair user from getting into a building. And that means there are places that wheelchair users are just excluded from, be it restaurants, offices, or even sports facilities. I've seen this firsthand. And a lot of the time, it goes something like this. My family and I, we decided on a restaurant to go to. And so we call ahead just to make sure it's accessible. We call and they say yes. And we drive over and we arrive and we see that there's a step in front of the entrance. Just a step. But that means we can't get in. And so we just have to head elsewhere or go back home. How can we prevent that situation? Well, it'd be a bit of a tall task. It would be difficult for all buildings to just suddenly become accessible. There are a lot of older buildings that weren't subject to the requirements of the Americans with Disabilities Act. And even with the ADA, a building that people might think is accessible might not be. And so the other option would be to find an easy way for wheelchair users to know ahead of time, before they leave their home, whether the building they're going to is wheelchair accessible or not. And so that approach begins with classification. I identified 8 key building features that determine whether or not a wheelchair user can get into a building. And those 8, as you see here, are automatic doors, flat ground, ramps, revolving doors, stairs, steps, thresholds, and uneven ground. And so 5 of these are inaccessible, and they can hinder a wheelchair user's ability to get into a building. The first one of those is revolving doors. Revolving doors can't fit a wheelchair. And so if you have a building with a revolving door, you're going to need another regular door in order for a wheelchair to be able to get in. Stairs too, they are insurmountable in a wheelchair. The same goes for steps. Even it seems like something so insignificant, but it can just exclude a wheelchair user from a building. And then there's thresholds. Thresholds being sort of like steps, but more of an incline that goes back down at the end. And those can be large or small. And so sometimes a wheelchair might be able to roll over a threshold just fine. And sometimes it blocks them from a building. And the final inaccessible feature of accessibility is uneven ground. And that's things like cobblestone. Because if you're on a wheelchair and you're rolling up to a building, it's going to make the ride really bumpy and you might even topple over. There's a risk of bone bruises, right? So those are the 5 features of accessibility that prevent a wheelchair user from getting into a building. And then there are the 3 that help, that are accessible. One of those is the automatic door. And that's especially helpful because it means that a wheelchair user doesn't have to push open a regular door, which is challenging when you're, sitting down in a wheelchair. Flat ground 2, it's the desirable surface. It's what wheelchair users are designed to roll on. And finally, you have ramps. And ramps can counteract an inaccessible feature like stairs by providing a smooth uphill surface that a wheelchair can roll on. And so those are the 8 key features I identified. There are definitely more. There are definitely a lot more, but I decided to start with these fundamental 8. So then I turned to machine learning, and I started this back in January. And back then, I was figuring out how I was going to make all this classification happen. And so I began by looking at the leading computer vision models, like the publicly available Amazon recognition and Google vision models. And, they're AWS and Google. So pretty powerful systems. But at the time, 9 months ago, when these models were shown a picture of a building entrance, they would see a business, they would see a store, they would see doors, architecture, but they wouldn't see the stairs leading up to the entrance. And a good thing, 9 months later, well, it's improved, but kinda, because just recently, like now, if you feed this picture into it, Google will say there's stairs with 62% certainty, but AWS recognition will give you this long, long list of attributes, and it can't identify those stairs. They're right in the middle of the picture, right? So 9 months ago, when I saw that these models weren't trained to recognize accessibility features, I realized I was going to have to train my own model. And I'd made text-based machine learning models before using R in the tidyverse. I made a random forest model that tried to predict whether a pitcher would throw a fastball or an off-speed pitch based on the conditions of a baseball game. It worked okay. But for this model, where I was analyzing images, I thought about using PyTorch or TensorFlow, but I ended up just using Google AutoML. For one, it made it super convenient to label images. Well, when I say super, relatively. It was an arduous process. It was difficult and long, but it provided still the ability to label somewhat easily. And the nice thing about Google AutoML, I had some machine learning experience, but even if you don't have machine learning experience, you can still use this technology. And so what I ended up doing is I scraped around 1,500 images from the internet and labeled them with these 8 major features. And then using Google AutoML, I trained the model. And to be honest with you, it didn't perform as well as I would have hoped. It ended up with an average precision of about 70%. An average precision is a combination of 2 other metrics, precision and recall. And so my model had a precision of 72%. And what that is the ratio of true positive predictions to total positive predictions. And it had 52% recall being the ratio of true positive predictions to total correct relevant predictions. And it's interesting to look at what the model did well with. It was right 92% of the time with uneven ground. It did pretty well with ramps. It did okay with automatic doors. And then you look down there and it only got threshold right 17% of the time. More often, when given an image of a threshold, it would guess flat ground. And that does make a little bit of sense to me, because thinking about the human vision, the thing that we'd be least likely to recognize is just a threshold in front of the door. It's something you might not even notice. And the model didn't do well with thresholds, and it did not that well either with stairs. And so I learned a couple things from working on this project. The first being, there are really a lot of buildings with inaccessible features. Just looking through the images I pulled from sites that display building entrances like Yelp, Google Street View. And the second thing I learned was that the designer of a building might not consider the perspective of a wheelchair user. And machine learning can have these kinds of blind spots too, with all the way from the beginning, the creation of labels to the finished model. AWS and Google now kind of include these accessibility features, which is a good thing. But just 9 months ago, they hadn't trained for it. Now, by no means am I free of the biases that many of us experience with the problems encountered by other types of disabilities and other minorities. I've only come to notice the challenges that wheelchair users face because of my experiences with my mom. Without that, I would probably overlook these problems. But it's important to think about how these human biases, the things that we aren't trained to see, it can affect what we do in machine learning and not. And so in the end, I'd really like 2 outcomes from this sort of model. The first being the ability to tell wheelchair users quickly whether a building they're going to is inaccessible or not, maybe by looking at Google Street View or something like that. And another is to let business owners know, hey, you might not have thought about it that much, but your building excludes people. Because both of those are important, the assistance of the disabled and opening the eyes of the able to the challenges that the disabled face. And there are a lot of challenges. There's a lot I haven't covered yet with respect to wheelchair accessibility, because building interiors can be just as bad as exteriors. And bathrooms without grab bars or wide enough maneuvering space can make a wheelchair user experience really, really difficult, right? Imagine being somewhere and knowing there's no way to go to the bathroom. Like, what would that do to your freedom? What would that do to your dignity? It's like the door is locked and everyone but you has a key. And so when it comes to these problems, we might not be able to remove the lock entirely. We can't easily do away with the parts of buildings that exclude wheelchair users, as much as I would like that. But using machine learning, we can work towards equal access. We can try to help restore some of the dignity that wheelchair users might lose. So I appreciate you all coming to listen, and I'm curious to hear any questions or comments you might have. If you work in the field, what do you think I missed? What do you think could be improved? I'll be in the networking lounge just after this if anyone has any questions or comments. Thank you.